In this lesson, we're going to take a look at using our order of operations. Please excuse my dear Aunt Sally. Parentheses, exponents, multiply, divide, add, subtract. And we're going to mix it in now with using variables. So you would have taken care of those lessons coming up to this point. Just a quick note, we know that one of these operations will no longer be part of our PEMDAS. They will no longer be part of our order of operations. We know it is subtraction, because subtraction gets changed into addition for multiple reasons, one of which is it's one less operation to worry about, and the other is we know how to add opposite numbers. So that's what we do. So now it becomes PEMDA. Please excuse my dear aunt. Does not matter what her name is. So we're going to take a look at variables just to get a few definitions out of the way. If I would see something that looks like this. Now you remember a variable stands for a number that we don't know. So this is an A, a B, a minus C, divided by D. First of all, this entire piece, this thing, is not necessarily called a problem. Its official name is, it's an expression. An expression is when I have numbers tied together with operations. Numbers and operations. So that's what makes an expression an expression. It's not a problem, it is an expression. Now, this one specifically has variables in it. So this is not just an expression, it is a variable expression. So that's what it is. Now, what do we do with it? Well, you remember with our PEMDA problems, we would funnel them down to one operation at a time. This process is known as evaluating. Since we're doing it, it's evaluating. We are evaluating it. So if somebody says evaluate this, what they mean is, what is the value of it? Find the answer. So this is what it is, this is what we do with it, and at the end, this is what we get. So those are just three things I wanted to get out of the way. This is what it is, this is what we do, this is what we get. The last piece of this becomes, okay, when I see a variable expression, what does each piece mean? What operation does each piece mean? What I want to do is take a look at a simple chart, add, subtract, multiply, divide, and the two variables I want to deal with, let's simply call them A and B. Now, again, I don't know what they are. Someone needs to tell me. Okay? So how do I show adding between two variables? There is only one symbol for add, and it looks like this. So if I would do A plus B, it looks like that. Okay? That's the only way I can write it. So when you do a PEMDA problem, a variable expression, if they mean add, it's going to look like this. Same with subtraction. If I wanted to subtract these two values, that's the only way I can write it. Now, the reason this chart becomes important is, okay, how do I show multiply? Typically, we think of multiply as the x. A, x, b. But there's a problem with writing this, a, x, b. There's a problem. I can't use this x to mean multiply anymore. Do you know why? What does the x now represent? X could be another number, because we're now dealing with variables where x gets used to represent its own number. I can no longer use it to mean multiply. So that becomes something that we cannot do. So there are other ways to write multiply between variables. One way is to put them side by side with nothing in between. This is an important one. So anytime I have two things, two items, two terms, side by side, it means multiply. I shouldn't say terms. I just mean two different values side by side means multiply. So this means A times B. Another way you might see is A with a dot and a B. Now notice it's not a decimal, it's in the middle, it's not at the bottom. So this could mean A times B. Sometimes parentheses get used to mean multiply. I could have A, parenthesis, B, and that could mean multiply. I could have parentheses around both. Parentheses around the A, parentheses around the B. Again, my same rule from earlier applies. Two values that are side by side like this means multiply. And depending if it's on a computer, you may see the asterisk or the star being used to mean multiply. Okay? And again, none of these symbols represent an x, which means its own number. Multiply is the big one. So let's go to division. Division is straightforward. You would see A divided by B. You would see something that looks like that. Or you would see A over B. And you have to remember, fractions, this is a fraction picture, actually means division. Okay, now let's take a look at taking my variable expression, evaluating it, and coming up with my answer. Now that we have an idea of what the pictures represent as far as operations. This is AB minus C divided by D. First of all, what does AB represent? Hopefully you see in your chart, AB represents multiply. So this actually is A times B. This says minus C. But what do we do with subtraction? Subtraction no longer exists. I should turn this to addition. Now my rule is change to addition, take the value next to it and make it its opposite. Okay, this is C. What's the opposite of C? Here's 7. What's the opposite of 7? Negative 7. Here's 10. What's the opposite of 10? Negative 10. Here's this number. What's the opposite of that number? Oh, put a negative sign in front. So I am going to change this right away so I know what to do. And then divide by D. Okay, so I want to evaluate this, but I don't know what the numbers are unless somebody tells me. So what I'm going to do is substitute out the variable and put in the value. A is playing a soccer game. Hey, he looks tired. You come out. I'm going to substitute you in. So A comes out. A 2 goes in. B comes out. B comes out, and a 3 goes in. Now, I can't leave it written like this because someone will think this is not 2 times 3. What will they think it is? They'll think it's the number 23. So this is when I have variables because you won't think this is the word add. Hopefully you think it is an A and times a B. So I'm going to pick a different symbol to use. I can pick any one of these. I'm going to pick the dot, 2 times 3, plus the opposite of C. What is the opposite of C? C is equal to 10. What is the opposite of 10? Negative 10. Divided by D. D is 5. So I substituted in my variables. Now I'm ready to evaluate. Normal order of operations. Multiply, add, divide. Which comes first? Multiply, divide go first from left to right. So multiply goes first. 2 times 3 is 6. I copy the rest of my expression down. We are doing one operation per line. Even if you can do it in your head, that's great. But we will show our algebra steps to get to my answer, not just from here to the answer. Plus negative 10, divide by 5. Next operation, I add or divide. Divide always is stronger. So I go here, negative 10, divide by 5. Different signs. I get a negative answer. I get negative 2. I still copy the rest of my expression down. 6 plus negative 2. One operation per line. You will work to funnel it down. You're not skipping steps to get to the end. Even if you can, we are not. We want to take our time and show our steps. Why? Because 6 plus negative 2 is 4. Variable expression. We now know what different pictures mean as far as operations. I changed any subtraction to addition right away. Substitute variables, do my order of operations. In other words, I evaluate, and I come up with my answer. Good luck.